My talk is based on my experiences in the Coast Action and Next that took place between 2014 and 18. And also I enriched my presentation by information of Elisabeth Schatzdorfer, who was a program leader of this Coast Action, and also Sina Heubel from the ETH Zurich, and Alan Burras, who have published 1 week ago a paper on tree projections in the future climate. So it's also based on this information. How does it go? So this way. Okay. So the title has many important words, and I first try to disentangle these words. I will talk on the roles. This means the current state of non-native tree species versus their future role. Then talking of this, this includes wood production and impacts on native ecosystems. Then the question on non-native tree species relates to the fact that they can be non-native to Europe, or they can non-native in different regions of Europe. This also includes that native tree species can be planted in different provenances at different locations where they haven't been in nature. Then about the future, this means we have to talk on climate scenarios and also of tree projections in these new climates. And then finally, as a synthesis, European forests, I will talk on forest occurrences, forest compositions, and the role of non-native tree species in these forests. Oh, this is the wrong one. So, okay. So first of all, this question, if I'm talking about non-native tree species mostly, I mean the ones that are non-native to Europe. They can come from Northern America mainly, and the well-known examples, Sitka spruce, Douglas fir, and Quercus rubra, for instance, they can come from Asia and Australia, and at that time they are phylogenetically more distant, like eucalyptus species, acacia species, or ailanthus species, but it can also come closer from Africa. And here the prominent example is Cedrus atlantica that has naturalized in the southern France. And to give some examples, and this is also context dependent. If you think of eucalyptus species, they are mostly planted in the Mediterranean area and in highest quantities in Portugal and in Spain. Sitka spruce is mostly planted in Great Britain, in Ireland and in Scotland, for instance. And then Douglas fir is widely distributed in France with more than 4% of the total area of the forest, and in Germany with more than 2% of the forest area, but also in general in Central Europe, as it is quite productive. And black locust is more widely distributed also towards the west, towards the east of Europe, and mainly in Hungary, and also in the Mediterranean area. Looking at the ones that have moved within Europe, most prominently we have large species that is widely distributed in Germany and in Great Britain to produce wood, and also Norway spruce is quite clear. The most important one is in Europe, then black pine and Castanea sativa, like very old species that were introduced in most areas by the Romans. If we sum up all these non-native tree species that are non-native to Europe and display this in black dots, we see like the distribution within Europe. And there are different patterns. One is that along the western coasts, the numbers or the blue color is dominating. It's also dominating in the lower area of Germany and France, up to Denmark, but it's also dominating in Hungary. looking at the percentages of the area, this becomes more obvious that in the United Kingdom, in Portugal, in the Netherlands, Belgium, and Denmark, we have highest percentages of the forest area covered by non-natives. And also again, in the east, this is Hungary with more than 30%. In contrast, we have also countries like Switzerland or Austria, where this percentage is below 1%. So compared to the rest of Europe, these are countries with very low amount of non-natives. If we look at the quantities of the cover of area, black locust is the one that is most widespread. Eucalyptus is also widespread. Sitka spruce, Douglas fir, and Pinus contorta, these all are introduced to produce wood in Europe. And another chart showing the number of different non-native tree species in Europe. We see that in Italy, for instance, we have a number of more than 80 different non-native tree species in the forests. And this is because of the high ecological range of different habitats in this country. But also in France, this number is very high. And in contrast, again, we have other countries with maybe, compared to Italy, a smaller quantity of different habitats. We have lower numbers. In summary, most of these non-native tree species in the forests have been introduced to produce wood, to increase the quantity of wood for the future. And so this is how it looks like. Mostly these are pure stands. So this brings then the question, how negative are these pure stands for the nature? And we tried to follow this question by the simple hypothesis that close to nature forests shouldn't be stressed by any non-natives. So the biodiversity and soil fertility should be high in these ecosystems compared to mixed forests and compared to the plantations. Very simple. So we tried to find comparisons of stands with close to nature forests, with stands with pure plantations or mixed forests, for conifers and for broadleaves. And we found in this action that was in the frame of the non-native next coast action, we found 103 papers that we could analyze, and this referred to 7 different non-native tree species. So there are more papers regarding these exact comparisons of non-native stands with native stands, but we only took the ones that we have sufficient statistical power to compare them. So there were only left 7 species to compare. And we could compare the soil properties with 720 comparisons. And we looked at nitrogen content of the topsoil, pH, CN ratio, and different other elements in the topsoil, and found that most studies show no significant difference between the native and the non-native stands. And this means most, about 60%, were with non-significant differences. And the other ones, 20% positive effects and 20% negative effects. So regarding the soil properties, it's not so easy to tell that these non-native trees have a fully negative impact. If you look at biodiversity then, we had in total almost 1,500 different comparisons. We looked at vascular plants, microorganisms, insects, um, bryophytes, birds. And you see, we only could compare about 4 different categories. And so the statistical power was not enough, not sufficient to compare all of them. However, we found then that in the majority, the different taxonomical groups were negatively affected. To give an example, the Douglas fir, for instance, there are less insects in the crown. There are enough insects in the topsoil, for instance, but not in the crown, which means that in wintertime, for instance, the birds cannot feed on the Douglas fir in contrast to different species in the wintertime. So this means that there are like interactions to different animal groups. So these effects combine effects of invasion traits and also on impacts on the nature have led to different legislative status in Europe. We see that of the coniferous non-native tree species, there is no constraint to the species, but for the broadleaf species, we have like a prohibition for Ailanthus, Alcenagudo, Punocerotina, Robinia, so black locust. These are in many places prohibited to be introduced or to be planted. So this is now, all these charts are now referring to the current state. But what is the future state of these tree species? And then we need to talk on the future of the climate. So we have here these different scenarios. New words, they are called SSP, so shared socioeconomic pathways, and they relate to the different increases of temperature as a main proxy. First of all, what happened until now during the last 20 or 21 years? Okay, it's not mine. This is a new study on the impact of extreme events that happened all around Europe in the forest area. Can we stop this? Okay. It's based on NDVI values that are calculated from the Landsat thematic mapper information. And if you see a green area in Europe, this means that there was no change of the color during the summer season in this year. If you see some changes, like for instance, it starts in 2003, at some places in Sardinia, we had some impacts. This means like brownish area in contrast to normally green area that is detected by this Landsat thematic mapper. And then nothing changes. At 2005, it starts to be different colors in Spain. 2007, 2008, again, different colors in the Mediterranean area, which means always different reasons. It can be infectation of the trees, it can be fire, it can be wind throw, it can be, so everything that makes the colors different. But if you look then in 2018, for instance, we see a big change of the colors based on the different impacts of the drought situation in 2018. This is increased already in 2019, and here the bark beetle infestation starts in the eastern area, and in 2022, this was up to then the highest difference in these colors. So we have now quite a huge impact of new extreme events all over Europe, not only in the Mediterranean area where it started, but also in the central parts and even in the northern parts. So this is also part of climate change and makes the question quite virulent: what should be the future species, tree species in our forests? So I give this only as a side effect of the climate change, because I will show you now different projections of a new paper of Sina Heubel that has appeared 1 week ago in Global Change Biology, showing the effects of climate suitability of tree species throughout the next 100 years based on the occurrence of 24 locally dominant species. What you see in red is change in species, the change of the occurrence of the species that was present between 1951 and 1980. So if you think all the area is almost red, this means the species that were present only a few decades ago won't be present in 80 to 100 years. It will be a full change of this species. If the area is blue, the area is still covered by the same species. So this is the case if we think of the projections in the normal way. Normal way means that there is the Gulf Stream active. But in that paper, they show also what would happen if the Gulf Stream wouldn't be active again. So and there are some new papers showing that this Gulf Stream will come to an end already 2060, something like that. This means there could be a change, and this change has been visualized. It means that at the let's see if we have some information. No, this information is gone. So this means that along the coast of the western coast, we have cooler temperatures. This means also that we have a higher snowpack during the winter time. This means that we have less precipitation in the western parts. This means that all the violet parts, these are areas where the trees that have been present only decades ago will be disappeared. So there won't be forests based on the species that were present. So we are talking here of European species. So in the violet area, there wouldn't be forest of the same species that were present only decades ago. In particular, if you look now in the normal situation with an intact Gulf Stream, this is the situation for Scots pine. It would disappear in France. It would be mostly disappear also in the central parts of Europe and only be present in the blue parts in this area. So this will be in Scandinavia. If you look at Norway spruce, this is the same effect. It will fully disappear from Central Europe. Then European beech would also disappear from Central Europe, and oak, Quercus robur, would be also only present in Scandinavia. Compared to this situation, if this Gulf Stream would be inactive. And here we have a higher disappearance of most of the species, except Quercus robur, it would be more spread in Europe. So I show this only to show that like the uncertainty of the future climate is quite high. If you think in normal terms, this would be like we know it already, that most of the species would move northward in general. But if we could think of this change of the Gulf Stream, it would be even worse. So this is another chart showing in blue areas the species that are covered by new species that come from the southern area, from the Mediterranean area, and colonize the area further north. And if you have the Gulf Stream inactive, it would be different. And this is how it moves. If we look at different, so I take some two examples, stone oak, Quercus ilex, that moves depending on the different scenarios, starting with the present occurrence at the left top chart to the SSP 5-degree scenario, where we see that this species is moving farther north and covering by the end of the century Europe. In contrast, the Norway spruce, it is already now quite at risk because of bark beetle infestation, and it moved further north, and the area would shrink in the Scandinavia. And these are different species to show to show what means which species would move further north. Betula pendula, Fraxinus excelsior, Quercus robur, Alnus glutinosa. What would be in the central parts of this of Europe? It would be Quercus ilex, Pilus aripensis, Pinus pinastra, Pinus nigra. So it would be quite a change of the species. That is my message here. There are not many models or model scenarios for non-native tree species, but one that was produced was of Silvio Schüler and Dave Chakraborty from Vienna, and they modeled Douglas fir at its current situation, the actual suitability in gray color, the ones that is the western, the coastal Douglas fir, and in black, the inland conifer, the inland Douglas fir. And in the extreme scenario 8.5, we see that at least in Scandinavia and the eastern and the northeastern parts of Europe, we have still the species left. And yeah. For Ficus sylvatica, there is also a new study for 7 different tree species in Europe. There are also studies, again, of Dev Chakraborty, who showed the differences regarding the different provenances of the species. So if you look only at one species as a whole, that was done by Burras and Menzel, we see that in an extreme climate scenario, that Ficus sylvatica will be restricted to the Scandinavian area, and this will be in more detail be the same if we look at the different provenances at the same scenario. It's not quite easy to compare these because they use different scenarios. However, we have like these differences if we considering also the different provenances, and there are some more, let's say, ranges that can move. Same for, no, excuse me. How does, so, hold on. Aha. This should be a different species. So this, I think this is Norway spruce, and this is Ficus sylvatica. Whatever. So, I mean, these different scenarios should also tell that the question in Europe, but also the question, especially in Switzerland, is which would be the future species if you think of that much different uncertainties based on different climate scenarios, based on different species. Would this native tree species be enough to cope with the future species, or should we also integrate some of the non-native tree species? This is really an important question, and not only the forests are looking for new solutions, but also research is looking for new solutions. This is an experiment, a big one, that was started 2 or 3 years ago in Switzerland, where we have at 56 different locations in Switzerland common gardens installed to plant a core set of 9 different species. Among them is also a non-native, the Douglas fir species, and an additional set, another 9 species that are planted in addition. This project is planned for the next 30 to 40 years to have not only seed trees during that time, but also to check and to compare the species performance at different locations and at different elevations. To show this, we have a range of elevations between 250 and 800 meters above sea level. So this is a quite huge range of ecological variability. And along this range, all of these different trees are planted along. We have 2 non-native trees to Europe and 1 that is non-native to Switzerland. So we integrate here not many of these non-native tree species, but the most important ones. This and the selection of these species is based on foresters' devices, so of practitioners. In addition, there is also a polytunnel greenhouse experiment where we push the species also to higher temperatures. So in these polytunnels, the trees are watered to the same amount as ambient. And as you can see, Quercus ceres is growing very well. This is a tree species from Far East and Mediterranean area. And it grows also at the north of the Alps. Same is Douglas fir and Cedrus atlantica, but also same is Quercus petrea. So we can, in the next 8 years, compare these different species. And to tell also in the openings of caused by windthrow in Switzerland, at many places Douglas fir is planted. So this is not a device by forest authorities, but the practitioners, they want to plant, they want to have a diversity in their openings, all together with native species. They want to have like an insurance against extreme events, but also like not too many pure stands, but intermixed in mixed stands. And also what is very new, that Castanea is planted on the north of the Alps. Is widespread in France and in the Mediterranean area, but is now planted not only by foresters, but even by farmers. They changed apple trees to castanea trees at the moment. So everybody is somehow preparing for the future. I come to the summary or the conclusions. The non-native tree species in Europe, they are varying in proportion and in cover at different countries. They have been traditionally used for wood production and will be used again for wood production. I don't know in which quantities, but of course it's a factor of wood production. Climate will change, it will be warmer, drier, and there is much uncertainty, which shows this example of the amok question. And if we think only in the normal scenarios, we have a northward shift of the native European tree species, and in the south we will lose the species, and the question arises, which of the species will follow at these areas? This means also that the characteristic wood production will be questioned. Principal tree species will vanish of the areas. Norway spruce is no longer an option in the lowlands in Germany or in Switzerland. Mixed species, so then some non-native tree species are suited to warmer climate, and this is the option to take. Mixed forests are an insurance for multiple forest uses to resist extreme events. And mixed forests are also a measure against massive impacts in soils and native biodiversity. So with that, thank you very much.